Hello everyone, welcome to my electronics channel. In today's video, we will be learning about the ESP32 microcontroller. The ESP32 is a power-packed and highly versatile microcontroller with capabilities like Wi-Fi, Bluetooth, SD card connectivity, then camera module connectivity, and is hence uh, it's quite an obvious choice for like IoT projects which implement the Internet of Things technology as well as the latest technical improvements in the industry like smart home, then home automation, Wi-Fi based the video calling or doorbells, as well as any other like IoT projects like vehicle tracking system or even like robotics. So this is a small chip. So as you can see over here, which is connected to the breadboard, and it is capable of accepting the USB power 5 volt DC and is provided by roughly like 38 pins by and which can like control various other like parameters as desired in like in any of the IoT projects. Okay, so we'll first go through the block diagram. So this is a functional block diagram for the ESP32, which shows various wireless protocols like the Bluetooth link controller, the Wi-Fi controller with the help of which you can connect to a home Wi-Fi network or even like remotely control any of those the things or sensors or any kind of electronic components and can control them via the internet from anywhere in the world. Okay, so it has a dual or a single core 32-bit processor, uh, ROM, then static RAM. So it has various like cryptographic hardware acceleration features like SHA, RSA, and AES technologies. The chip is also capable of receiving as well as transmitting the radio frequency signals, and at the same time, it is capable of various communication protocols like SPI or the serial to peripheral interface, the, then the I2C, I2S, the SDIO, so with the help of which you can communicate with any like micro SD cards. Then the UART or Universal Asynchronous Receiver Transmitter can then the Ethernet, infrared, as well as it has like 16 PWM like output pins with the help of which we can like design various output like projects in the electronics area. The chip also comes with a temperature sensor. So it has capacitive touch sensors as well, with the help of which you can uh, like wake up the chip from the sleep from a deep sleep mode, and at the same time it has like digital to analog and like analog to digital converters as well. So it is quite a versatile chip, and there are like various like implementations like smart home automation, long range Wi-Fi communications, various IoT device implementations, sensor monitoring, then MQTT based implementation with the help of IoT, like AWS IoT implementation. Everything can be achieved with the help of this ESP32 device. Okay, uh, so once connected with various like electronic sensors like the temperature sensor DHT11, as well as uh, the barometric pressure, the humidity sensor like BMP 180 or BMP 280. This IoT based chip ESP32 can actually serve as a full-fledged weather station or even a weather and temperature monitoring station. Okay. Now in this video we will be doing a very simple uh, like program to control the LED or to blink an LED with the help of this ESP32, and writing a small program in Arduino IDE to control the blinking of an LED. Okay. So before jumping to the program, we'll see some of the specifications of of this ESP32. So the board accepts 5 volt DC as an like input power supply voltage. The board actually works with 3.3 volt DC as the operational voltage. So so surely there is a voltage regulator which converts the 5 volt USB the DC into a 3.3 volt operating voltage. The minimum the operating current required is 500 milliampere. though at like every pin level, the current drawn per general purpose IO pin or per GPIO pin is maximum of 40 milliamperes. Okay, the board is based on a single chip, which is ESP32 W room 32-bit. Uh, the CPU is made from Extensa and it's a 32-bit processor. The clock frequency range is 80 to 240 megahertz. So it provides a 512 KB RAM, a 4 MB external flash memory, roughly 34 general purpose IO pins, which is capable of doing like any other general purpose input output activities. There are 18 analog to digital channels, and like all of them are like 12 bit. There are two digital to analog channels, which helps to convert a digital signal to an analog voltage, which is 8-bit resolution. And there are a variety of communication interfaces, as we showed it on the functional diagram, like SPI, I2C, I2S, UART, with the help of which you can connect to various other interfacing systems like the SD card or a camera module, or even like GSM 900 like SIM based module for like GPRS data transfer as well. The major the usage of this ESP32 is for Wi-Fi and Bluetooth communications. For the Wi-Fi, it is able to connect to any home routers or home wireless network, and at the same time, it uses the Bluetooth like low energy or the BLE, and as well as the classic Bluetooth features. It also has an inbuilt wireless antenna as part of the PCB itself. Okay, so these are some of the specifications. So let's go to the actual connections, and we will try to run the program with the help of that. Okay. Uh, so in this program, we will be trying to connect to one LED with the help of a 220 ohms resistor, and we will be like sending an output voltage of high to the general purpose IO pin G2. Okay, and the LED will be connected to ground and via the resistors of 220 ohms. Okay, so this is a schematic diagram. Uh, so next we'll switch on to the Arduino program. So it's very simple. We are like using the general purpose IO pin number 2 to provide the high voltage to the LED. So at an interval of 1000 milliseconds, which is 1 second, we are calling the method digital write to provide a high voltage to the LED pin, which is pin number 2, and then after an interval of 1 second, I'm providing low voltage. So alternately, the LED should blink as high and low at an interval of 1 second whenever the program is run. Okay, so this is a very simple example of connecting an, an ESP32 board to the breadboard and then providing or to control the general purpose IO pins with the help of some input signals. Okay, so let's jump into the working video. So here's a working video of the ESP32 Devkit V2 board, in which I have connected one LED with a resistor to the pin number G2 here, and the other end of the LED is connected to the ground. Okay, and programmatically I'm setting the G2 pin high and low within an interval of 1000 millisecond, which is 1 second. So the voltage level at the pin G2 is high and then low at an interval of 1 second. So that is what is being reflected with the blinking LED. So friends, if you liked this video and found it useful for your electronics learning, please hit like and subscribe to my channel and provide support and encouragement. Thanks so much for watching.